Number 35 of your summer assignment asks you to find the piecewise defined equation that represents a given graph. The given graph is in three parts. The leftmost part is a half circle. It's the top half of a circle whose center is 0, 0, and its radius is 1. Such a circle, as you know, will have the equation x squared plus y squared equals 1 squared. And we solve this for y. Y squared is 1 squared, which is 1, minus x squared. Y is equal to plus or minus the square root of 1 minus x squared. And the top half of the graph is when we take the plus sign because the y's are all positive. So I start with f of x is equal to positive, and then the square root of 1 minus x squared. And this applies when x is sandwiched between negative 1 and 1, including the endpoints. The second part of the graph, which I've highlighted in yellow, is pretty easy. That is part of the horizontal line y equals 2, and this applies for the x values that are sandwiched between positive 1 and 2, and we're not including the endpoint, so I don't put in the equal sign. I think it is the part of the graph that is highlighted in green that I think gave people the most trouble. And if you think about it, that line segment is part of a line that continues indefinitely, and I need to find its equation. There are two ways of finding its equation, and I'll show you both ways. One method for finding equation of this line. All right, method 1. Okay, I find 2 points on the line. One point is easy, 4, 0. The other point is 2, 1. The slope, therefore, is going to be 1 minus 0 over 2 minus 4, or 1 over negative 2. Therefore, the equation of the line is, remember we use y minus y1 equals m times x minus x1. So I've got y minus, and I'll pick 4, 0, a little easier to work with. Y minus 0 equals negative a half x minus 4. If I distribute that, I get y equals negative a half x plus 2. So I go back up, and to complete my piecewise defined function, that was negative a half x plus 2, and that applied when x was between 2 and 4, not including 2, but yes, including 4, and we're done. Let's just look very quickly at another method, method 2, for finding the equation of the line, and that is using a visual inspection and using the slope, which is rise over run. You've known that for a long time, okay? If you think about this green line segment, the rise is going to be 1 unit, but I'm going down, so it's negative 1, and the run is 2 units. So let's mark that on my diagram. The rise is negative 1, because we always go from left to right. Okay, so going left to right, if I start at this point and I go left to right, The so-called rise is a drop of -1, and the run is +2. It's -1 in the y direction, +2 in the x direction. So I can write down straight away that my slope is going to be equal to -1/2. And now I use that to count backwards to see when I'm going to hit the y-axis. I'm now at this point again here, 2, 1. All right? The slope was 1 down, 2 across. So where was I if I went 1 down and 2 across? Well, here's 2 across, 1 down. Oh, it would take me to this point. Therefore, my y-intercept is 2, and using your old friend, y equals mx plus b, we get the same equation, and that's it.